Have you ever looked out at a rolling green hill or a deep valley and wondered how it actually got its shape? To figure it out, imagine a wooden classroom desk. On it, we have a stack of different colored paper and a block of soft, wet clay. The ground beneath our feet feels completely solid, but over millions of years, the Earth's crust behaves exactly like the items on this desk. If you push it hard enough, it can bend, and if you pull it, it can break. By seeing how paper wrinkles and clay slices, we can understand exactly how the tallest mountains and the deepest valleys across the African continent were built. Africa's landscape is a physical record of these hidden internal forces, which have spent millions of years pushing and pulling the crust into the shapes we live on today. Let's start with bending. If you take that stack of paper on our desk, place your hands on the edges and squeeze them together, the paper buckles upward. The Earth does the exact same thing when immense underground pressures push flat rock layers together. This creates giant waves of solid rock. The crests, or upfolds, are called anticlines, and the deep dips in between, the downfolds, are called synclines. This squeezing process is known as folding. It is the exact force that crumpled the rock layers of North Africa to build the towering peaks and valleys of the Atlas Mountains. But not all rocks can bend. Remember the clay on our desk? If you pull the edges of stiff clay apart, it cracks. When tectonic forces pull the Earth apart, brittle rocks snap, creating deep vertical fractures called faults. If two parallel cracks form side by side, the land in the middle loses its support. It sinks straight down into the crust. This creates a deep valley floor bordered by steep, tall cliff walls, known as escarpments. Look closely at this photograph. You can see a wide, flat valley floor sitting far below tall, rocky walls. This is the Great African Rift Valley, a massive trench stretching across the continent created by this exact cracking process. Every towering peak and plunging trench we see is a physical record of the Earth's crust yielding to intense pressure. Sometimes those cracks go incredibly deep. They reach all the way down toward the Earth's mantle, where rock is so hot it exists as a glowing liquid called magma. The immense pressure forces this liquid rock up toward the surface. Once it bursts through the crust, we call it lava. As the lava meets the cooler air, it hardens. Over multiple eruptions, layers of hardened rock pile up around the vent, building a steep, cone-shaped volcanic mountain. This photograph shows the dark, rocky craters of Mount Cameroon in West Central Africa. It was built entirely of cooled magma that escaped from deep underground. Once these massive high-altitude mountains and plateaus are in place, they dictate something else entirely: water. Gravity ensures that all the rainwater falling on these highlands has to run downwards. The incredibly steep slopes of the land act like a giant slide. They channel heavy rains into wildly rushing rivers, sending the Nile flowing north to the Mediterranean Sea, and pooling massive amounts of water into the deep River Congo in the continent's center. As a river nears the flat coastal plains, it slows down. A river like the Niger splits into a network of smaller streams, dropping rich, fertile soil to form a wide, fan-shaped area called a delta, right before it reaches the ocean. The physical shape of the continent acts as a massive natural plumbing system, catching rainwater in the highlands and deciding exactly where it flows to support life. These geological formations determine the survival of civilizations across Africa, acting as storehouses for the resources people need to thrive. This image shows green terraces cut directly into a rugged mountainside. Over time, volcanic ash breaks down into incredibly fertile soil. Because of this, highland areas attract huge farming communities growing reliable crops. Down in the vast, flat highlands known as plateaus, the ancient rocks trap valuable minerals. In Nigeria, for example, the raised expanse of the Jos Plateau holds rich deposits of tin, creating a thriving mining industry. This photograph highlights a massive concrete dam blocking a wide river valley. When millions of gallons of water rush down a steep incline, engineers can capture that powerful flow to generate electricity for entire regions. This satellite image tracks a large body of water called Lake Chad in the dry Sahara region. Because it sits in a shallow depression rather than a deep trench, it relies on local rain and is highly vulnerable to drying up during droughts. The same tectonic shifts that fractured and folded the Earth millions of years ago now provide the fertile soil, abundant fresh water, and renewable energy that power African communities today.